What do all those planes have in common? Well, they have these little fins on their wings. They're called winglets, and they're not just there to look cool. They're the result of over a century of aerodynamic problem solving, and they save airlines millions every year. Ever since humans first flew, engineers have been in constant battle against drag. They learned early on that a wing produces lift by creating high pressure underneath and low pressure above. But at the tips, something nasty happens. The air spills around and swirls upward, forming what's called a wingtip vortex. Those swirling mini tornadoes saps energy and slow the plane down. This picture right here, I believe, perfectly demonstrates what it is. In the early days, these vortices were more of a curiosity than a problem engineers could solve. Planes flew slower and fuel was much cheaper, so inefficiency wasn't a big priority. But as speeds increased and airlines started flying further, that wasted energy became too expensive to ignore. Reducing drag wasn't just about going faster, it was about going farther on the same tank of fuel. The answer wouldn't come from an airline or a manufacturer, it came from NASA. In the 1970s, with fuel prices climbing and efficiency becoming critical, one engineer decided to take a fresh look at the wingtip. That engineer was Richard Whitcomb, already famous for inventing the supercritical wing, as you can see in this photo. Lengthening wings could reduce drag, but longer wings are heavier, more expensive, and often don't fit at airport gates. Whitcomb's alternative was simple but brilliant: a vertical extension at the tip, carefully shaped and angled to push the swirling air upward. Wind tunnel tests proved these winglets could cut induced drag and boost efficiency by several percent. In aviation, that's massive. The first winglets to fly weren't on big passenger planes, they were on small business jets. The results were immediate: longer range, better climb performance, and lower fuel burn, all without completely redesigning the wing. The technology was promising, but commercial airlines still had to be convinced. In 1988, Boeing introduced their 747-400, which was one of the first big jets to sport these tall, curved winglets, unseen in the previous variants of the 747. And indeed, they worked. Cutting drag by reducing wingtip vortices meant less fuel burn and longer range. By the late 1990s and early 2000s, winglets began appearing on mainstream airliners. Boeing offered them on the 737 NGs and 757 and retrofitted them to the 767, saving up to 500,000 gallons of fuel per plane per year. Now, of course, if you look back at older versions of these planes, like the Boeing 767-200 or the early models of the 737, you won't see winglets at all. Back then, the focus was different. Wings were designed for stability and structural strength, but the fuel-saving benefits of winglets weren't yet fully realized or prioritized. Adding winglets later became a popular retrofit as airlines looked to improve efficiency without buying new planes. Winglets' biggest advantage happens on longer flights. The longer the flight, the more fuel they save by cutting drag. For shorter flights, the benefit shrinks, and on very short routes, winglets can actually be a disadvantage. Why? Because winglets add weight and planes spend more time taking off and landing relative to cruising, so the fuel savings don't really add up. That's exactly why Japan Airlines uses winglet-equipped 767s on their longer international flights, for example, Tokyo to Vancouver or Tokyo to Honolulu, but keeps their non-winglet 767s for short domestic hops. For the 747 family, the 400D version was designed especially for Japan's domestic market, and it had its winglets removed for this reason. Similarly, Scandinavian Airlines used to operate some 737-700s and 800s without winglets because most of those planes flew short Scandinavian routes where winglets just weren't worth the extra weight and cost. By now, you might be wondering, why don't the 787 Dreamliner and some other modern planes have traditional winglets. Well, the 787 and Airbus A350, for example, skip traditional winglets in favor of raked wingtips. These are longer, angled extensions that act like stretched out winglets. They smooth out the air just as effectively, but also boost lift and cruise efficiently. Winglets might look like simple little fins on a wing, but behind that simplicity is a story of smart design. They help planes fly more efficiently, saving fuel and reducing emissions with every takeoff and landings. So while they may seem small, winglets play a big role in modern aviation. A quiet, powerful tool that helps airlines save millions, reduce their environmental impact, and keep air travel moving forward. So next time you're on a plane, take a moment to enjoy and look out the window at that little fin on the wing. It's a small detail, but with a big purpose. So, that concludes our story. Thank you for watching, and as always, see you in the skies.